actually make it across this circuit from here to here. This is my, whatever it is I'm trying to do with it. Everything else is in the power supply. 8.1?
Yeah, 8.18, so 8.2.
So the voltage across this 10 ohm resistor, same power supply, everything else being the same, is, well, it's going to be 9 volts. That's what drives the circuit. In a perfect world, if you drop such a small amount of current, the internal resistance doesn't matter. Then you're going to get basically the same voltage output. .82.
8.1. Oh, it's
0.81 is 0.82. Whoa, wait a second, what's going on? That's the current, that's not the, that's the current.
If you multiply that.
Sorry. This is the current. So the volts across this thing, which would be the effective voltage,
That's
would be 8.18 volts. If you need 9 volts of power across here, then really what you need is 0.9 amperes of current. If you could only generate 0.82 amperes because your effective voltage is 8.18, your power supply or your battery is lacking. The effective voltage output is lower than it would be otherwise. It still might work if you draw very little current from it, but as a battery goes, it's not a very good battery. As a general rule, this dynamic of internal resistance will be very small, usually under an ohm, but it will rise with time as the battery dies. The voltage, the potential difference, is set by the chemical reaction itself. That's the energetics of the reaction. But the power output, which is related to how much current you can get out at any given time, is rate limited by all those factors inside. So typically when we say a battery is getting old, what we mean is the internal resistance is rising in the battery. That's our fundamental model of dead batteries. If you measure a dead battery up until the point that the chemical reaction doesn't happen at all, when you measure what's essentially a dead battery, like your remote control doesn't work anymore, but it just stopped working, usually what that means is you've still got 9 volts or whatever of power, or I'm sorry, voltage potential difference, but you just can't generate enough current because it's not making it past the internal resistance, if you will. So you limit your power output. So that's a tricky concept. Think about that when we talk about that. When we start lab, we'll talk about how this relates now to capacitors. Same exact principle, only you add a dynamic component to it. It's fascinating.
Lithium ion at this point.
So what is a battery? It's basically a rated voltage source with some kind of an internal resistance in there that limits its output. For all batteries, though. Because nothing is perfect in this world. You can't just draw 100 amperes because you've got 9 volts. Always limited by everything inside. And by the way, the more power gets driven across here, guess what happens to the battery?
What?
If more power is required to drive across this internal resistance, what happens to the battery?
Just dies.
It gets hot.
Yeah.
Right? Batteries get hot because the internal resistance physically takes energy just to generate the current across that internal resistance. You can even think of it as being an infinite internal resistance, which, and in the limit, a resistance that is functionally infinite is essentially an open, like having an open,
Email that to
open front circuit.
tomorrow's lab.
But really what it means is just you guys know more things to chemically
So we
react.
need to come tomorrow. get the data.
Oh,
Because he's not coming in tomorrow, so he already did the land.
Oh, wow. Awesome.
So
Okay.
it should be fairly quick.
Thanks.
They always have to have some sort of charge.
Oh, bro.
So they take some sort of what?
You guys wanna get together to work on the project, or
So
should we just
what can I do?
communicate through email, chat, Skype,
But
whatever?
eventually we'll need to get together.
Eventually, probably,
Yeah, I think eventually we'll have to.
The problem with sodium is
So we
that
won't start
the chemical
talking about the
reaction
actual
process doesn't
presentation,
generate
once we
much
have all the
energy.
pieces
It
that
has
go
a-
into
it
the
has a lower
presentation.
effective voltage.
Actually building that will probably require us.
And you know,
to
see, that's not true, it's the other way around.
Skype
It's
works
actually
okay,
higher.
but, you know,
Yeah.
It actually has
that's
a
what I thought.
higher,
to have
um,
a outline in front of you of an order of
let's
events.
see, lithium is above sodium. Sodium is too explosive.
Rehearsal.
Sodium is too
Well,
energetic.
as a team leader
So
so far,
lithium is
I mean, I
safe.
started reading the.
So it's actually, it's on the slower end, not the higher
Reading
end.
articles about all that stuff.
So, because I mean, in terms of just pure
I mean, is there
power,
anything
energy
specific you
output,
wanna focus
you do
on that
something like
subject,
cesium
or?
or barium,
Just
and you have
like
a lot of
general,
energy.
what-
you know.
What actually preceded that
But
thing?
lithium is a little bit
That's what we
slower
use
on
to
the.
for it, so
on the
I
reaction.
haven't put
So,
really.
I forget what the other part of
Me neither,
lithium
it's
is.
like I was just generally
In the
just.
chemical reaction, but
He's putting those types.
essentially what happens with most of these
That's
is
what we
that
need
the
to start
product
talking
that's
about
formed
is, who wants to cover what material so that we can be a little bit more.
Coats.
efficient. So,
the reaction surface.
I wrote some things down when I talked to Tony last, and,
Okay, so think about it
so
this way.
I
It's
will
not
send
quite
out
right. I'll tell you
all
why
of
it's
that,
not
so
quite
that,
right.
you know,
It's
generally
usually
know
not the
what it
brine
is
itself that's
needs to be
changing,
researched.
but what it is that whatever other thing is chemically
We want to follow
reacting.
that sheet that they
For
gave
instance,
us.
let's see,
Yeah,
Yeah,
that's
Say you
probably
had
the best, and say, all those questions.
lithium ion,
I mean, it pretty much outlines.
and it has a choice of
the entire
chemically
plan, how it should
reacting
be.
with
So say,
chloride or
say
hydroxide.
he researches what preceded that knowledge.
Lithium
Let's say
is-
I research, or you
It's
research
probably
how,
that example too, because this is not.
what drove the explore and how they did the experiments, and
Might be
say,
sulfate,
I
but
will
we'll
research
go with this.
what came out of it.
Lithium is soluble
Probably help
when it's in the
somehow put it all
lithium chloride,
together.
just like table salt, it just dissolves in
Yeah.
water. So if you've got a
He
little
gave me some.
box here, it's
what I
got
mean
water
by
in it.
What Tony gave me.
Lithium
Yes, we have that
chloride
sheet, and that's what we
is
should work from,
aqueous.
but he gave
So
me
you
some
end up getting
kind of
this,
starters
this, and
of
they're just
names
all
to
over
look
the
up,
place, just
of people
floating
that
around,
are
okay?
working
Now,
just
when
prior
lithium
to
hydroxide is formed,
what Fermi was doing.
it's not
So that
soluble.
you have, you
This
can
is a
read what they were
precipitate.
doing.
Oh.
So this will either form some powder on
I
the
mean,
bottom,
it's
Oh, yeah.
or
Yeah,
it will
that's
form
right.
some pattern
I'm personally
powder
interested in
on
what came out of
on
it.
the electrode.
Right.
So
You
let's
can't
say,
get that back.
even the structure
A
of
lot
nuclear
harder to get
reactors
that
or
off.
stuff like that,
Okay.
Silver
I mean,
batteries.
I would focus on results, and if you want to focus on the preceded work.
Copper
definitely.
chloride,
And then
or copper hydroxide, yeah, there's a few different ones, so.
I kind of
So
beat
again,
up this
I cannot
piece.
specifically remember what's going on in here, but
That's why hydrochloric acid separates.
I like
those. Pretty attractive.
Ready-made results.
Yeah.
Right, right. Well, that sounds
yeah,
like
so typically what you have
easily
is
be,
something
your
that
contribution. is
chemically
on that
reacts
side.
to release the chloride
And I
ion
don't know, I don't know how much
from the lithium.
actually
And it may be,
you can expand, because we don't really want to make
You
it
could do
too
any
broad, like,
number of
it's not gonna be
things,
separated too long and not
ultimately, the
focused on
question
what the hell
is,
you're talking
if you
about.
start
right.
here,
I think you maybe, say, somehow
so
incorporate
think
how
about it this way.
nuclear reactors came out of
So
it,
we've got lithium chloride, there's a
how they were
plus, and
built
there's a
before in the
minus.
seventies, how they
And,
built now, I think even, like I know now they have,
and it's
they're
dissolved,
making,
so
like,
really
not
it's
a nuclear
lithium
reactor,
plus
in case of a meltdown,
chloride.
they have those cases.
Now, if you
that
have a
it's meltdown,
secondary, if you
meltdown,
have a
the case of
reaction
process
with,
not
say,
gonna come. Or at least, it's not gonna go just.
example,
Atmosphere, like
If you have
happened
water,
in Chernobyl.
and you
Yeah,
convert
it just
that
melted
water
and that's it,
into
all over the place, not
Right.
hydrogen
And everything is still
and
Yeah,
hydroxide.
dead,
This
it's
is
still
not,
like a 10-mile radius.
oh no, yeah, you can
Yeah.
absolutely
It's like-
do this. It's been a while since I've taught
We
chemistry.
don't country will that be around.
As this goes up relative to this is where you
It's
can.
huge,
shift
yeah.
to hydroxide.
Yeah, so that, yeah, that sounds like a good plan.
Okay, well, yeah, like I said,
And in the process,
I'll send out a.
You get this
those,
hydrogen.
At least, at the very least,
that
those
hydrogen
names
then
and
can
those
combine with
research
something
points.
else and can give up an electron,
Sounds good.
another metal, for
We
instance.
talked through that.
say,
Now I'm gonna
an
figure out why
electrode
is the
that
resistance
has.
rising inside the battery and,
Right.
not just the voltage dropping, but the.
Say- Say copper.
Well,
So-
suppose,
Copper can give an electron to this.
I don't know if this is right, but
And the hydrogen
Suppose
becomes,
you've got some kind of chemical.
and it's not
right?
hydrogen,
And
it
when it
ends up being
reacts,
something else.
you have some. kind of
Hypothetically,
byproduct,
it becomes hydrogen,
And that byproduct.
but in the
builds
process,
up.
this copper
Gets in the
becomes Cu plus.
So
Now
why
the
don't we
copper
have
soluble,
batteries?
this
Well,
decreases, and now you've got the
Then
hydrogen.
that chemical
Now, if
reaction
this here is
occurs.
not physically hydrogen, but it's
That's a good
something
thing,
else,
yeah, maybe it's right.
this could in effect also coat this surface.
It's just like.
If it weren't hydroxide, if it were some
Makes sense.
chloride compound or sulfate compound or something. I'd have to look up the specific, I've long forgot any of
It's
these
been a while
chemical
since I've taken
reactions.
your class too.
Or
so
lead
it's-
sulfate.
That's probably what it is, obviously.
Yeah, no.
If
What
there's
ends
some
up
kind of
happening is
byproduct,
it's
it's
usually,
probably-
it's in this case often
Right.
towards the other
That-
ion, and they end up coating this thing, which means it can't chemically react. And even if it can a little bit,
Yeah.
when you start depleting all that lithium or whatever else, and you can't get that free, then it won't necessarily go back the other direction. So usually it's an issue of the coating of this electrode. I have to look this up now, I'm just driving me nuts, 'cause I forgot. Or it's the formation of the precipitate that you can't get back.
Yeah. I can't help but imagine that this is the same as a nuclear reactor, and here's the fuel rods right here, but just picture wise, like, yeah, we're.
Yeah, and then you surround it with copper rods to slow down the reaction rate.
Between the-
Yeah, and basically as this gets coated, it slows down the output of the neutrons, so they don't speed up and interact with other fuel rods as quickly.
Structural principle and giant reactor.
Yeah, it's all, I mean, every process is the same, whether it's happening in the nucleus, or whether it's happening chemically, or whether it's happening with static charge. It always ends up being the same process. The question is just what are the players and just how reversible and how much energy is involved with the process.
So for a super simple battery here, you've got one material here,
Mm-hmm.
and you've got some other material here.
Mm-hmm.
And this one has, I guess, actually this one would have, if this is the positive side, then this one has the excess electrons, right?
Yes.
So they go, and they react with this, that is starved for electrons. And then you end up having a buildup of some kind of, this one after it's been depleted of its electrons, and this one after it has gained its electrons, right? As this thing is.
It's usually not happening here.
Well-
It's usually happening at the electrode end, so it would be here
Okay,
and here.
but as that,
And then
as
you've
that
got some
material
little
is
salt
building up,
bridge that allows the charge to balance and go through.
as that material is building up of this no longer reactive stuff, that's what creates this increase in resistance, right?
It's non-conductive. Salts are
Right.
non-conductive, metals are conductive. Salts and precipitated salts especially are non-conductive.
Radioactive salts, no.
And so if you get, among other things, if you get too much coated, then there's no current left to push it back, or I'm sorry, to keep going. But if you try to recharge it, but it's completely coated to the point that there's no access, it won't run backwards.
Is there always-
Because you cannot get the reactants from here to react with what's in the core. There has to be some minimal access between the two to run it backwards. And as soon as you basically completely coat it, it won't happen. So yeah, so when you deplete a battery of that kind, then you're stuck.
So how do you recharge a battery? And how?
Well, usually that happens very slowly and it doesn't happen completely. If it doesn't happen completely, then you can take another power supply that will push current back in, and that will reverse the chemical reactions that happened, and it will basically remove the coating.
Yeah.
So it's like electroplating and then the reverse of electroplating.
So what's the difference between the regular batteries and rechargeable batteries? Why can't you just take a regular battery and recharge it?
It's just the stuff that's inside.
It's not reversible?
They're a little bit reversible, but not very much.
So you can recharge it, it's not gonna be the same, it's just gonna less for real longer.
Sometimes they'll explode, sometimes they'll just heat up and explode.
That sounds like fun.
That is good. Nice.
Every time I hear those kind of things, I'm just like, ooh, something
Let's
new to
blow
try.
something up.
Exactly. Oh, they are fun.
You know what,
And batteries are a field unto themselves now, because among other things now, because of the high rates of power output that these things have to have now, and the fact they operate over long periods of time, they have to have all kinds of built-in things inside here to keep them cool, so they don't
Yeah,
overheat.
that's right.
And so they don't explode, because the things that are inside are oftentimes reactive with air.
Yeah, Samsung has like a processor somewhere.
And so, yes, they've got all these backup safety things that will shut off if they get too hot, or if they draw too much current.
Oh.
Rather than just explode, or rather than just pop, they just shut themselves off.
Oh.
And they're a serious safety hazard if they don't, because they can explode.
and then they call them copper top. So,
The popper top,
copper top,
as opposed to a copper top?
yeah. So, when I was a freshman in high school,
Thrown in the fire.
I failed freshman science. And I had to come back and take it during summer school. But, we
Russ, the
had,
summer school kid. Like,
Well-
yeah, you know, that whole group of people, the summer school kids.
right, well, so that was the class with the, I don't know if this
Smoking at
is,
recess in between classes in the bathroom.
no smoking, but this is what I did in class. I would find various objects and melt them. That's what I did during class. I would find various
With lighters?
things
With a lighter, or rub them together?
with like an oil burner, like an oil wick burner.
Fuck yeah.
I would take the wick out a little further than it should be and then spread it so I'd get this great big flame.
And the teacher never said, what the hell are you doing over there?
Teacher wasn't doing anything. I'm sure they probably did several times.
You just kept doing it? They didn't
Well-
just take it away from you? I guess you just bring another one to school.
It wasn't mine, it was lab materials.
Oh, okay.
Yeah, which I was ruining.
I
But
used to do those things at home. I used to love to take rubber balls, and I'd hold them with a pair of pliers, and I'd light it on fire. Because those
My
things
favorite
are
thing-
just a hot burner, but it'd make the whole house this noxious black smoke. And, you know, you smell 3 whiffs of that, and you're like, oh, this isn't good. You blow a starter, you run outside. Yeah, it's like, oh God, I gotta get the door wafted now, my mom's gonna smell it, I'm in deep shit.
I like to try to get little green flecks in the flame by burning copper. And I liked to melt
Magnesium's
new pennies, or new-ish pennies, because the zinc inside would melt faster than the copper on the outside, so then you'd have this malleable sack of molten zinc that you could play with. Then you could pop it with a pin and pour the zinc out, and then have this empty copper,
Oh, nice.
You know.
Nice.
and that's what I did. Now, the
Future
summer
scientists waiting to have,
Access to
to
materials.
emerge,
Of
yeah.
course you would.
Some
Right.
exploration.
that summer school
You think
class.
of metallurgy now, is that metallurgic engineering?
No, not at all. That was just me fiddling, you know. Instead of talking about the sludge test, which was, is the sludge test universal, or is that just a whatever
I've never
school
heard of
district?
it.
The sludge test was the thing from freshman science that you had to do or you couldn't graduate. And I think it was statewide, because there was some kind of like rubric for it.
Of course,
It
I'm
was
very
standard.
old, so
They-
I don't know, it
yeah.
may have happened, it may have
I've
been
heard about that
instituted after I
happening,
graduated.
Like the freshman in my class, when I went out to senior, and, yeah, they had to go through that.
What they did is they take a beaker and they throw a bunch of crap in it, and then you could look in the beaker and say, oh, well, it has some popsicle sticks, and it's got some combination of ethyl alcohol and water, based on the odor, you know, and some other crap in there. But you can't just use those kind of observations. You have to analyze it by, you know, distilling it and measuring the boiling points.
Really?
Yeah. And
Never
then
had to do- never
and
got
then
to do
use
that.
all of this stuff to identify all the different parts, and then identify their ratios, and then, you know, that
Okay.
was your.
That can't
that was
be
your test.
currently going on, because nobody would ever
Yeah,
graduate.
that's not gonna work,
Well,
at least in.
Unless
I-
the teachers
A
are
lot of
giving,
schools,
you know,
like, you know.
everything, but there's, oh, really,
My
there's wood,
summer
carbon,
school-
blah, 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 there's one thing missing, I bet you could smell it. A, you pass. I don't know, they gotta do something, because there's no way.
Yeah.
It's,
Well, I
That's
think
a cool- that's a
I think I
cool-
remember, you know, the boiling point of whatever this alcohol was, you know, like 77 Celsius, and, you know, the water was 100 Celsius, you know, so all the alcohol would boil off first, and then you'd boil off all the water, and then you have this,
the sludge.
you know, whatever was left in it, you know.
That would take a while too, you couldn't just do that in.
Yeah, it was, no, it was like a week-long project,
Oh, okay.
and
Others,
yeah, it's not like an exam, really. You get scored on it, and you get scored on a scale of 1 to 6 on like 4 different
As
categories.
long as you get one of them. you-
And as long as you get like 4s on everything, then you get to graduate.
Or you get summer school?
Okay,
Well, I didn't do the sludge test the first time around, I didn't do anything. So during summer school, it was like, okay, well, I have 5 days, 5 hours each day to just do this thing. And I just did it and got my, you know,
And then
3
played
6s
around
and a
with the science
5
equipment after
and
that.
left.
Oh, okay.
You know, and I was like, if I could take every high school class in 5 days, at 5 hours a day, I could leave now and get back to my drums and my video games without anybody giving me a hard time. But yeah,
Well, you know, it's the important stuff, that's it, that's what matters. It's-
I used to, you know, I used to screw up so much that I would have other students pissed at me. You know, not just my teachers, you know, because my teachers always give me a hard time, you know, but other students, you know, you are
Like so people partying.
just completely wasting
You
taxpayer
get the rubber
dollars and
hose.
yada yada.
In the Soviet Union, they didn't have allowed that.
Oh, gosh, I would just, most of the time, do just enough to get the D, get
Wow.
out.
I was way too early for that.
And I, you know, well,
I had to
I
be
was-
the best
I
with
was-
the least amount of effort possible, and it had to be obvious that it was the least amount of effort possible. So,
well, I was still arrogant. I